So this is part B of the same lecture 1.1, the tangent problem. We had a technical malfunction, so I'll continue here. We're looking at the table and we see that as x is approaching 1, remember x is the coordinate of our point Q, so as x is approaching 1, P is approaching Q. So our secant becomes a tangent. We see from the pattern for the slope of PQ that the closer x is to 1, the closer the slope is to 2. So we can assume at this point, we're just looking at examples and patterns, so we're assuming that the slope of our tangent line is 2. So we're going to investigate this concept in more detail later, and we'll find that the slope of the tangent line, t, is the limit of the slope of the second line, which we call the secant line. In other words, if I take the limit of the slope of the secant line PQ and let P approach, we're going to let Q approach P, which is the same as x approaching 1. So that limit is equal to m, which is the slope of our tangent line. And we can write that the limit of x squared minus 1 over x minus 1 when x approaches 1 is 2. So now we have a point, a fixed point that's given. We have the point P that was given with coordinates 1, 1. We assume the slope is 2, so we can write equation of a line using the point slope form. So y minus y1 equals mx minus x1. We call this point slope form, where you know the point and the slope. Substitute. So y minus 1 equals 2, x minus 1. Simplify. Y minus 1 equals 2x minus 2, and y equals 2x minus 1. This is the equation of our tangent line T. This is the equation of the tangent to the curve at the point P, 1, 1. So note if we change the point, the tangent will have a different equation. If we change the curve, we'll have a different equation. So does that make sense? Let's look at the curve, the tangent that we drew, 2x minus 1. Looks like the red line has a y-intercept about -1 and a slope 2. So one more time, let's write down that the limit of the slope of the secant line when Q approaches P is 2. And that is the case whether Q approaches P from left or from right. It doesn't matter. In our case, we had Q approaching P from the right, but we'll get the same conclusion if it's approaching from the left. And this concludes the lecture for 1.5. 1.4.